Hello everyone, I hope everybody is fine. And in this lecture, we're going to learn about the derivative of a logarithmic function. So we have f of x equals log of x base a, and we want to find the derivative of this logarithmic function. That's the question we want to answer. What is the derivative of a logarithmic function log of x base a? So we're going to start with the theoretical definition of a derivative, which is limit of f at x plus h minus f of x over h when h approaches 0. And then we are going to substitute, instead of f at x plus h, we're going to have log of x plus h minus log of x all over h when h approaches 0. So we start with the theoretical definition of a derivative, that famous quotient, limit of the quotient, f at x plus h minus f of x over h when h approaches 0. This will be limit of log of x plus h, of course, to the base a. Base of the logarithm could be any positive number except 1. And log of x plus h minus log of x over h, we have to find this limit when h approaches 0. So clearly, if h approaches 0, the numerator approaches 0, the denominator approaches 0, this is indeterminate form. We have to find somehow to find this limit. So I'm going to use the laws of logarithm. So we know that difference of two logs would be log of a quotient. It was called the quotient law of logarithm. So this would be log of x plus h over x base a when h approaches 0. Okay, and then we are going to rewrite this as log of 1 plus h over x all over h when h approaches 0. Please note that h is the main variable and x is not the main variable here, because h is approaching 0, not x approaching 0. So here we're going to say let h over x equal to some new variable n. Okay, and then we're going to argue, we're going to say if h approaches 0, then n approaches 0 as well. We're changing the variable basically, not sending rocks to the moon. So it will be limit of log base a of 1 plus n, okay? And instead of h, we can write x times n by a simple cross multiplication. So x times n. So we're going to say limit of 1 over h, which becomes 1 over xn when n approaches 0. So I can rewrite this as limit of 1 over x times 1 over n, right? And then times log base a of 1 plus n. That's how I can rewrite this limit. And then x is not the main variable, so I'm going to even pull it out. So it's going to be 1 over x times limit of when h approaches 0 of, not h, sorry, n approaches 0. So this is n approaching 0. Let me write it clear. N approaching 0 of log of 1 plus n to the exponent of 1 over n. So what I did, I applied the power law of logarithm, and 1 over n was a coefficient for the log. I put it in the exponent part. So now I have log of 1 plus n raised to the exponent of 1 over n. We have to take the limit of this when n approaches 0. Now, logarithmic function is a continuous function, and there is a property of limits that says limit of a function equals, or limit of logarithmic function equals to the logarithm of the limit of that function. So I can write this as log of limit of 1 plus n to the exponent of 1 over n when n approaches 0, and the base is a. So limit of log equals log of limit, because logarithmic function is a continuous function. So This limit, you might recall that it was the irrational number e. Limit of 1 plus n to the exponent of 1 over n when n approaches 0 is equal to e. We have learned about this in the past. So now we have 1 over x times log of e base a. And using change of base formula, we can say this is actually ln of e over ln of a. Okay, log of e base a can be written as log of e base e over log of a base e. So ln of e over ln of a. But ln of e in the numerator is 1. So we have 1 over x times 1 over ln of a. And this is the final answer. So the answer to the question, what is the derivative of logarithmic function log of x base a, becomes 1 over x ln a. So let me rewrite this. Y equals log base a of x. The derivative is 1 over x times ln of a. This is what we wanted to prove. Okay, now the question is, what if the base of the log is e itself? What if we have y equals ln of x? Well, it's not that difficult, because if the value of a happens to be exactly equal to e, then in the formula, instead of ln of a, we're going to have ln of e. But ln of e is 1, therefore the answer becomes even easier, even simpler, as simply 1 over x. So derivative of natural logarithm of x is 1 over x. The derivative of log of x base a is 1 over x ln a in the denominator. Two important formulas we derived. Now I'm going to combine this with chain rule actually. What if we have log of u base a, and u is a function of x instead of being x itself? For example, what if we have y equals, let me write it at the corner here, y equals log of x squared plus 5x to the base 7. Okay, so this is log of u, log of some function of x, in this case quadratic function. Well, we have to apply chain rule here. So what we should do, we have to take the derivative of inside, which is playing the role of u prime for us, which would be 2x plus 5. So that's the derivative of x squared plus 5x with respect to x, and then times it by the derivative of the logarithmic function, which would be 1 over u, which is x squared plus 5x, and then times ln of 7, whatever the base is. So that becomes the derivative of this function. You may say let u equal x squared plus 5x, and then du over dx would be 2x plus 5, which we called it u prime. And then you can say if y is log base 7 of u, then dy over du, derivative of y with respect to u, would be found from the formula 1 over u times ln of a. In this case, I should write ln of 7, right? Ln of 7, because a is 7. So back substitution for u would give you 1 over x squared plus 5x times ln of 7. So that's dy over du in terms of x. And this is du over dx. And we know the chain rule in Leibniz notation that dy over dx is actually dy over du times du over dx. So du over dx is 2x plus 5. It's right here. So this would be 2x plus 5. And dy over du is just what I got over there. That's right there. And when you multiply them, you get exactly the same answer I got here earlier. So it works out to be correct. So making long story short, log of u base e would be u prime over u ln of a. It becomes a shortcut formula, maybe not in the book, but logarithm of a function u to the base a would be u prime over u ln a. Now, same formula for the natural logarithm. I mean ln of u, it would be u prime over u, very simple. So these are the two other formulas. In total, there's 4 formulas for logarithmic derivatives. And I can give you just a couple of examples here. So let me erase this top part and quickly give you a couple of examples. If you have, for example, 4x ln of pi x, okay, 4x times ln of pi x, the derivative would be derivative of first. This is a product rule, by the way. This is a product. We have to apply product rule. So it would be derivative of first times the second, which is 4 times ln of pi x, plus derivative of second times the first, which is 4x times. Now, what is derivative of ln of pi x? In other words, ln of u. Well, ln of u, the derivative is u prime over u. So it's going to be derivative of pi x, which is pi over u, which is pi x itself. And needless to say that pi over pi cancel out each other. X over x would cancel out each other. So this would be just simply 4. So the final answer would be 4 plus 4 ln of pi x. You may, of course, factor 4 out as well if you feel like it. So 4 times brackets 1 plus ln of pi x would be the final answer for the derivative of this product function. Okay, and then maybe another example of log base 2 of square root of x plus 1. What is the derivative of this function? Well, which one of these 4 formulas should we apply? I think we have to use this one, log of u base a. So the answer is u prime, which is the derivative of the radical. So that would be 1 over 2 square root of x plus 1. Okay, that's u prime in the numerator, divided by u ln of a becomes the radical, that's u, and ln of a would be ln of 2 in this case. Now, simplifying it a little bit, we get 1 over 2 times x plus 1 ln of 2, final answer. So this is the final answer to the derivative of log of square root of x plus 1 to the base 2. Okay, I hope you understood these 4 logarithmic formulas and you did take notes. Give you a couple of examples. We can do more. There's 4 other formulas for exponential functions, which I will explain them later to you.